Hello boys and girls, welcome to Unit 1, Domain and Range. Today what we're going to be discussing is your foundational skills of domain and range. If you're looking for correlating textbook pages, you'll notice they are located here at the top right hand corner of your notes. We're going to begin with this small organizer. We're going to fill in the missing spaces and we're going to get a little bit of understanding about domain and range before we go through some examples. The first thing we're going to define is the word relation. A relation is a pairing of independent and dependent values. As you're going to see in a few minutes, we can also call these inputs and outputs. A function is defined as a relation, which has a very special relationship between its x and y values. Every independent value, remember those are your x values, has exactly one dependent value paired with it. So if I were to draw a small little graph off to the side, and I choose a point on the x-axis, let's say 3, I cannot have 3, 1 and 3, negative 1 and have a function. Remember your vertical line test? Alright, your domain is a set of all inputs values. Your range is your set of all output values. In just a few minutes, we're going to take a look at some different examples. So as we go through each one of these examples, we're going to talk about two very important characteristics. First, in the graph, we're going to talk about continuous, discontinuous, and discrete. And obviously, in our notations, we will be talking about interval, set, and roster. Please understand the differences between both so that you can determine those when it comes to assessments or questions in class. So if I put my pencil on the left side of this graph and I trace it through all the way to the right side of the graph, I don't pick up the pencil at all. In other words, there are no holes, breaks, or discontinuities in the graph. Therefore, it is determined to be continuous. Interval notation uses parentheses or brackets. Brackets will include values, much like a closed circle did on a number line. Parentheses will exclude values, much like an open circle on a number line. All right? The way we determine included or excluded on a graph is by looking for those holes, breaks, or removable discontinuities. What we're looking at here is we're looking at an unbroken line with arrows at the end of it. The arrows signify that this graph will continue in both directions, left and up, forever. Likewise, this arrow signifies that this graph will continue in both directions, right and up, forever. Therefore, the interval over which this graph exists is going to begin where this arrow stops, and while it never stops, we signify that with a symbol called infinity. Because this graph is traveling to the left, we are going to use that part for domain. Remember, domain is all the x values. You just learned that from the definition above. So we go to the left as far as we can. The arrow takes us to negative infinity. Remember, when we do these notations, we use counting order. So interval starts at the bottom, set will start at the bottom or the smallest number, so on and so forth. Okay? Now we go ahead and we take a look at our graph. Now, because we're dealing with domain, we want to know the direction that this graph is traveling to the right. Remember, it's traveling to the right and up at the same time, but we're only concerned with its rightward movement. Now that arrow means that it'll never stop, moving towards the right. Therefore, we will use infinity. Now, in interval notation, remember we're talking about whether to use brackets or parentheses. The reason why we will use parentheses here is because the term infinity can never be reached. Therefore, by default, it's an excluded value. Okay? Domain to range is typically read from left to right. Therefore, domain is typically read from left to right. Range is up, down to up. So let's go ahead and take a look at that right now. The graph does not exist down here in any place. Therefore, we cannot say that it begins at negative infinity. Otherwise, part of this graph would be pointing in the downward direction, and it's not. So we're going to go from the bottom of the graph, and we're just going to keep moving up and up and up and up and up until we find the place where the graph is at its lowest. Now notice this is on the y-axis, but if the graph was situated over here, I would do the exact same thing and find the corresponding y value. Remember, range is y values. Now, it starts at the number 1. And it continues up and up and up. Remember, these lines travel in two directions. This curve, left and up. This curve, right and up. Now, because we're dealing with range, we're only concerned with the upward motion of the line. Therefore, we're going to say that this graph ends at infinity. Now, because there is no hole, open circle, or break at the number 1, it is an included value. And that is the interval notation for this continuous function. Set notation is a different type of notation which uses brackets to surround inequality symbols. Okay? Now when we're looking at this, same thing is going to apply. The inequality symbol will tell you whether it's included or excluded value. Remember, this line underneath means equal to. Therefore, if it's less than or equal to or greater than or equal to, it is included and a closed circle. If it's less than or greater than, it's excluded and an open circle. Now with domain and range in set notation, we will be defining what domain is. So we begin with a bracket and domain is x. We will be separating that with a vertical line, and then we will set our parameter for domain. Now because we're dealing with domain starts at the left, we're going to find the place where this curve stops moving to the left. And that is way down here at negative infinity. And then where this curve stops going to the right is also at positive infinity. We have a new term for that. It's called all real numbers. It can be written as a capital R with a double line at the beginning. And then I close that bracket. Range is going to be written the same way. Define what range is. And now we start at the bottom of the graph. The bottom of the graph is still at 1. And the number 1 is the smallest value and it's included. So 1 is less than or equal to y. Now it's not necessary for you to write less than or equal to anything else over here, because if you have no restriction on this side of the range, it is assumed that the graph continues on and on forever. Roster notation is written just like set notation, with one very important difference. Roster notation is only used for discrete relations or discrete functions. Moving on down to our second example, we will, forgot part A and B. In part A, what we're doing is we're defining the value of some points inside of this continuous function. So we have to be able to read this properly, all right? So in words, this means when x equals 2, what? is y? That's what it's asking. Another way to write this is as an ordered pair, because it's f of x equals, we're just substituting the value of x for 2. So in an ordered pair, I'm going to write it as 2y, where I've got to use the graph to figure out what y is when x equals 2. So I'm going to go over here to 2, and I'm going to look for the corresponding y value at the point where it touches the graph. Therefore, the ordered pair at this place is 2, 5, so the answer to this question is 5. For what values of x does f of x equal 2? Well, we're going to look at this in the exact same way, except opposite. In this case, f of x is the same as y. So substituting y for 2 looks like this. What is the value of x when y equals 2? So I'm going to go back up to my continuous function here, and I'm going to find the y value at 2. If I go to the right, I notice there's an ordered pair at 1, 2. Likewise, if I go to the left, there's also an ordered pair at 2. And now you see the reason for the s in parentheses here. It could be one value, or it could be more than one. In this case, x is going to equal both -1 and 1. So be observant to that and pay attention. All right, now we can move on to question number 2. All right, in question number 2, you'll notice that you're given a set of ordered pairs. Therefore, you are given a discrete function. Discrete functions are scatter plots. So if I were to graph this, it would look something like this. Discrete functions are scatter plots. Now, interval is a very important term when you're dealing with discrete functions. When you have dots on a graph, you have points, singular points in space. Interval notation requires that there is some sort of distance between those points in order to define it. Therefore, discrete functions are impossible to write in interval notation. All right. That means now we have a chance to look at set and roster notation here. Remember, for set notation, we are going to be defining our value. The domain is x. Now, the way we're going to write this is in ascending order or counting order, okay? And lucky for us, it's written that way now. 17 over 2, well, 16 over 2 is 8, so that's 8.5. -4, 1, 7, 17 over 2, and 12. Now in this case, because we're writing this in ascending order, we will also be writing this in ascending order. Remember, when you're stating domain and range, the ordered pairs do not have to line up in the table. You are simply telling the reader or the person interpreting your work that you know all of the y values and they do not have to correspond to the set of domain values. So that's going to be -2, 4, 7, and 13. You'll also notice that the number 7 is written twice in our range. We only write it once when we're stating what the range actually is. Now, the only difference between set and roster notation is that in roster notation, we do not have to define the values x and y. So it's -4, 1, 7, 17 halves, and 12. -2, 4, 7, and 13. Pretty straightforward so far. Remember, we're determining the difference between the types of functions that you will see this year, as well as the types of notations that you're going to express their domains and ranges in. All right, example number 3. Example number 3 introduces a hole, a break, a removable discontinuity. Now, if I take my pencil and I draw from left to right, notice that I have to pick up my pencil and jump to this line because there's a hole there, an undefined value, an exclusion. So that means that this is a discontinuous function. With it being discontinuous and not discrete, roster notation is out. All right, let's go back to interval notation. Remember, we've got to set up our brackets and parentheses appropriately. We're going to introduce a new term here called a union. Okay? A union helps us skip over those gaps that show up in the graph without missing any values of the domain or range. All right? So we're going to travel left on our domain. As I travel left, I notice that the graph starts at the value -6. -6 has a closed circle. Since it's an included value, I will represent it as a bracket. Now I'm going to travel on that domain to the right until I come to the open circle, the break in the graph. That open circle occurs at the number 2. Because 2 has an open circle on it, I'm going to put a parenthesis around it because it's an excluded value. Here's where the union symbol comes in. I need to start a new interval on the other side of the 2. Remember, I approached it from the negative side. Now I'm going to be leaving it on the positive side. Okay, so think of it as 2 different sides of that little 2 there. There's the negative side of the 2, and then there's the positive side of the 2. So now that I'm on the positive side of the 2, I'm going to pick my interval up again at that undefined value. But remember, it's excluded, so I put parentheses around it. And then, of course, I travel on my domain to the right until I get to a place where the graph stops. And in this case, it doesn't, so it continues on to infinity. And remember, infinity is always excluded, so that's why it's got a parenthesis there. All right, with the range, now we're going to travel from the bottom of the graph up. Notice the first place I encounter the graph is at the number -5. Now this could be a little bit tricky, but we look at overlaps here. This is defined in the range because it's part of the line. This part is undefined in the range. So which one wins? Well, if you have an undefined value and a defined one, this one wins. It covers up the whole. Okay? That means that I'm going to begin with a bracket because this line covers up that whole. I'm going to continue on my y value up and up and up and up, and I'm going to find the place where the graph stops. The graph stops at the number 7. Because that's a closed circle, it's included brackets. Set notation. We've got to define what domain is, and domain is x. And then we're going to continue on. We start at the value that is to the most left of the graph. That's -6. And we're going to say that that is less than or equal to x. Now, some people would say, okay, I'm going to go from -6 to 2. Then I'm going to put a union symbol, and I'm going to start again. But we're not dealing with interval notation here. We're dealing with inequalities. All right? So we're going to introduce a new symbol that we can use to help us show this value. So instead of saying -6 less than or equal to x, which is less than 2, and then saying union less than 2, 2 less than x, and continuing on from there, we're simply going to say that all of the domain is -6 to infinity except x does not equal 2. And that is how we write it without using the union symbol. So we're going to really try to keep the union symbol in interval notation and then use these inequality symbols to help us with our set notation. All right, now we get to the y. And that's going to be -5. Now remember, this line covered up that closed circle, so it's included. And then it goes all the way up to the value of 7. And remember, that's also included, so that's why it gets the equals to as well. All right, we'll get back to our values here. F of 2. All right, so using the same logic as before, when x equals 2, what is y? Okay, so I'm going to go over here to x. When x is 2, what's the corresponding ordered pair? Well, that's 2, -5. But wait, what is at the value of -5? A whole. Therefore, the answer -5 is not correct here. The answer is actually no value, or what I like to say, does not exist. Other things you might see here are undefined. Your calculator is definitely going to give you an error message, but we'll talk about that later. Does not exist is what that acronym is. For what value of x does f of x equal 1? Well, remember, f of x is y. Let's write that again so we remember. Okay, so when y is 1 right there. So what's the corresponding ordered pair? There it is. That's going to be -2, 1. So it's going to be -2. Now the s doesn't apply here because the graph doesn't have any other defined values at that point. All right. Question number 4, and our final example for today. Take some time right now to pause the video, run through this example ahead of me, and see if your work matches mine, and see how strong your understanding of interval set notation is at this point in time. All right, hopefully you've taken the opportunity to work this ahead of me. It really does not help if you just keep following along. You've got to do some independent practice with some supports. Okay, so now what we're going to do is we're going to take a look at interval notation first. In our domain, we travel all the way to the left at the start of this graph. Well, it starts at -8. The value of -8 is an included value because it's a closed circle. And I'm going to go to my first interval. My first interval will end at the value of -5. The reason why I know it ends is because there's a gap there, a break. I'm going to go ahead and exclude that value, create my union because I know I've got another interval coming up because I've got more graph to follow through on here. I go from -5, and here's where people might differ on this. Some might say, okay, the next interval is to here. Well, that's not true. If I were tracing this with my pencil, I would go right on through that dot, and I would not have to pick up my pencil. So my interval does not stop at -1. My interval stops at 3. Now, if you were working on this on your own, and you added that little interval in there from -5 to 1, -1, and then went from -1 to 3 as a third union, it's technically wrong, but it's just not written efficiently. Okay, so really try to think carefully about what included and excluded means in interval notation. Now, the reason we have parentheses here, obviously, is because of that open circle. All right, the range at the bottom, okay, is -3. And that's an included value. Now I'm going to travel up to the top of this graph and see what's going on. All the way across, both of these top values of the range are open circles. That means the value of 1 is excluded, leaving me parentheses there. All right? Remember, for set notation, we have to define our value. Oops, about to write a y there. That would not have been good. All right, so domain is x, and we're going to go ahead and start with our leftmost value of the domain, -8, less than or equal to x. And we're going to travel all the way through to the end of our graph, and that stops at 3. And remember, that's an excluded value, so there's no equal to there. Now remember what I said. Rather than using the union symbol, let's use that does not equal to symbol instead. Well, along this whole graph right here, there's one place where it is not defined in the domain, and that value is -5. All right, and again, we'll define our range, and that's going to be -3 less than or equal to y, which is less than 1. Now, what is the reason that we don't use roster notation? Because this is a discontinuous graph. Remember, the only time we use discrete or roster is on a discrete function or relation. All right, so f of 2. So when x equals 2, what is y? All right, so let's go ahead and find that. X equals 2 occurs right there. The ordered pair is 2, 0. For what value or values of x does f of x equal negative 1? Well, remember, f of x is just y. So let's go ahead and find negative 1. All right, so negative 1 is there. I'm going to scan across to find my corresponding points. Oh, there's one. So that's going to be negative, or 1, negative 1. All right, there's another one. And that's negative 3, negative 1. And there's my last one right there, which is negative 7, negative 1. So there are actually 3 corresponding values here. We'll start at the smallest of the 3, negative 7, negative 3, and 1. So hopefully you've had some time to digest the different terms, domain, range, relation, function, discontinuous, continuous, discrete, interval, set, and roster. Please take a look at those. Come to class prepared with any questions that you might have tomorrow, and we'll be ready to study a little bit more and do some more independent practice with this in class.